Okay, so today we've got something really special. We've managed to get our hands on a complete design document for a next generation AI system. It is incredibly detailed, it's super ambitious, and, well, it's got a twist that makes it feel like it's from another time entirely.
And here's the kicker. Check out the date on this thing, March 2026. Yeah, so what we have here is, for all intents and purposes, a bug report from the future. We're going to deconstruct this system, which is called the Data Media Machine v3.0, and see what its amazing goals and its critical flaws can teach us about building AI right now.
And the vision behind this project, wow, it is absolutely incredible. The whole point of DMM v3.0 was to create AI-generated video that wasn't just some fantasy, but was actually anchored to reality. It was designed to tap into live webcam feeds from all over Los Angeles to generate video that reflects what the city actually looks like in real time. Okay, so here's our game plan. First, we'll look at this artifact from 2026 itself. Then, we'll dive into its incredible vision for a reality-grounded AI. After that, well, the story takes a turn, because the code review begins, and that's where we find the big risks and the hidden traps. And finally, we'll pull it all together and see what lessons we can learn from this bug in the future. So what is this thing really? Well, this document lays out the entire blueprint for an AI video pipeline. The whole system is designed to grab live images from public webcams all across LA. Freeway cams, skyline cams, beach cams, you name it, and then use those images as the jumping off point for AI-generated video. And this is really the core idea, the whole reason this project is so cool. The vision was to stop creating AI videos in a vacuum. Instead of just typing a text prompt and getting a completely hallucinated scene, DMMV 3.0 would start with an actual picture of the world, creating something that's part real and part artificial. This table from the doc really lays out the massive leap they were trying to make. See, their old version, 2.5, was pure text to video, totally made up stuff. But with version 3.0, the video source becomes live webcams. The visual grounding goes from none to real LA webcam frames. That's the whole ballgame right there. And here's how it was all supposed to work, step by step. The pipeline would first fetch real-time data, think weather, traffic reports. Then it would pick the right webcam, grab a single frame from it, get that image ready, and then feed it into an AI video model to animate it. Simple enough, right? Okay, now this part is just brilliant. The system was designed to basically link its own creativity to live data. So think about it. On a calm, sunny day with light traffic, the AI would create really subtle, realistic animation. But if there's a crisis, a huge traffic jam, bad air quality, it would get more creative, generating these dramatic, intense, almost cinematic videos. Super clever. So the vision is amazing, right? But, and this is a big but, this is where things take a turn. Because we don't just have the design document, we also have the code reviews that went with it. And the engineers from the future who analyzed this thing, yet they found some serious show-stopping problems. So that begs the question, right? Does this incredible, ambitious design actually hold up when you put it under a microscope? The reviewers dug deep into the code and the architecture, and what they found is just a masterclass in the huge difference between a great idea and a system that actually works. So let's start with the heavy hitters. The reviewers pointed out several high-priority risks. I mean, these are the kinds of fundamental design flaws that could make the entire project just fall apart. And they gave them these great, kind of ominous names. The fallback burden, the CPU denoise bottleneck, and the all-time classic problem of breaking existing workflows. Let's take a look at a couple of these. First up, the fallback burden. Now, the idea was simple enough. If a webcam fails, just try another one. The problem is the software it was built on, Comfy UI, uses something called a directed acyclic graph. Think of it like a production line. Data flows in one direction, from start to finish. It never loops back. So this try again idea creates a loop, which just fights the fundamental nature of the software. The review nailed it when they called it a trap. And this right here perfectly explains that second risk. See, to add some new features, a core part of the system was changed to have 3 outputs instead of 2. Now, to you and me, that sounds tiny, insignificant. But to the system, it's a catastrophic change that would instantly break every single project built on the old version. A huge, flashing red flag for compatibility. All right, so Beyond those big, obvious architectural flaws, the review also dug up some of these really clever, almost hidden bugs. These are the kinds of edge cases that only pop up when you try to connect a clean, logical system to our messy, unpredictable real world. And I gotta say, these two are my absolute favorites: the timestamp trap and the time zone trap. One is about a camera that's frozen solid but tricks the system into thinking it's live. And the other is about a system that thinks it's nighttime in LA when it's actually broad daylight, just because the server is sitting in London. So to get what's going on with the timestamp trap, you need to know about this thing called stale frame detection. Basically, it's a clever trick the system uses to see if a camera is frozen. It uses a method called the Structural Similarity Index, or SSIM, to compare two different pictures from a webcam. The magic number here is 0.97. See, the SSIM score goes from -1 to 1, where 1 means two pictures are perfectly identical. So the rule is, if the similarity between two frames is over 97%, meaning they're almost exactly the same, the system flags that camera feed as probably being stale or frozen. But, and here is the genius of this trap, a lot of these public webcams burn a digital timestamp right onto the image. So even if the picture of the freeway is totally frozen, that little digital clock in the corner is still ticking away. And those few changing pixels, that's just enough to make the SSIM score dip below 0.97, fooling the system into thinking the entire video feed is live when it's completely not. So, after tearing apart this system from the future, we've seen the brilliant ideas and the killer flaws. What does it all mean? What can this bug report from 2026 actually teach us about the challenges we're dealing with right here, today? I think this quote from the review just sums it up perfectly. This whole document, this whole project, it's really a case study in that enormous gap that exists between a fantastic AI idea on a whiteboard and a system that actually works day in and day out in the real world. So if you remember anything, remember these three things. First, great ideas almost always create brand new, complex problems that you never saw coming. Second, real-world data is just messy. Timestamps, time zones, frozen feeds, and AI systems are often fragile when they meet that mess. And finally, the hardest part isn't the big idea. It's closing that huge gap between the design doc and code that actually reliably works. And I'll just leave you with this final thought. We've been poking around in a bug report from 2026, but as we build more and more complex AI that has to interact with the real world, how many of these so-called future problems, from broken workflows to clever timestamp traps, are actually our problems right now, hiding in the systems we're building today? It's definitely something to think about.